So we have a rectangle, there it is, and a right-angled triangle, there it is. And we're given dimensions in terms of x rather than just numbers. And we're told that all the measurements are in centimetres. And we are told that the area of the rectangle is greater than the area of the triangle. And we're asked to find the set of possible values of x. Okay, so there isn't a huge amount of information here. The key thing clearly is that the area of the rectangle is greater than the area of the triangle. That is essentially an inequality. So let's write it down. Area of rectangle, okay, I should use a little sort of pictogram there, is greater than the area of the triangle. Okay, so I've made it clear what I'm doing. I've translated the question into something that looks a bit like maths. Let's make it look more like maths by actually putting the areas in. Okay, so a rectangle is the length times the width. So let's do that. So 3x minus 2 times x minus 1, that's the area of the rectangle, is bigger than, what's the area of a triangle? Well, I don't really need to remind you, but there it is just in case. It's a half the base times the height. And in the right angle triangle, the base and the height are the two sides at right angles. So that's greater than a half of the base, which is x, times the height, which is, I don't really need a bracket, 2x. There we go. Now let's see if we can sort this out. We have an inequality here to solve, and at the moment it doesn't look very helpful. So on the left, what have we got? Two brackets. Let's multiply them out. How do I do that? Well, there are lots of ways of doing it, but I like to use FOIL. What does FOIL stand for? First, outer, inner, last. How does that work? Well, we take the first term in each bracket and multiply them together. So 3x times x is 3x squared. And then we take the outer pair of terms. 3x times minus 1 is minus 3x. Take the inner pair, that's minus 2 times x is minus 2x. And then take the last one in each bracket. Minus 2 times minus 1 is plus 2. What about the right-hand side of the inequality? Well, you'll notice a half and 2 multiplied together. And of course, a half and 2 cancel, because when they're multiplied together, a half times 2 is 1. And what's left? I've got x times x, which is x squared. Right, so let's lump things together on the left-hand side. The only things that lump together are the minus 3x and the minus 2x. So I get left with 3x squared minus 5x, that's minus 3 minus 2 is minus 5, plus 2 is greater than x squared. And because it's a quadratic, clearly, with x squareds in it, I want to get a 0 on one side, so I'm going to subtract x squared from both sides. And so I have 2x squared minus 5x plus 2 is greater than 0. Right, how do I solve quadratic inequalities? Well, here's, I hope, a helpful blue box. Okay, and it says quadratic inequalities, and it says always factorize. Okay, so we'll do that in a minute. Sketch a graph and then use the x-axis as a number line, and there is a little example there. Okay, let's just have a quick look at that example. So if I had something like x squared minus 4x minus 5 is greater than 0, I would factorize x plus 1, x minus 5, and that tells me that the roots of this function that I'm going to sketch are minus 1 and plus 5. And so I can sketch my graph. I'll do that in more detail in a minute. And then I'm looking for the bits where it's greater than 0. In other words, above the axis. And so it's all the bits above 5 and all the bits below minus 1. And there, having used that as a number line, we translate it into an inequality. Okay. Well, let's do that with this one. So the first thing I need to do is factorize. Now, although this is a slightly difficult one, actually, there isn't much choice in what I can do. I've got 2x squared, so that's 2x times 2, and I've also got 2 at the other end. And given I've got a minus sign in the middle, that must be minus 2 times minus 1. And I can't put the minus 2 in the left-hand bracket there. Why not? Because that would give me a factor of 2, and there's no factor of 2 in there. So actually, I don't have much choice. That must be the minus 1 there and the minus 2 there. There are other ways of factorising that, but that was a sort of a quick, intuitive way of doing it. So what does that give me? Well, that gives me the roots. And so the roots of this function are something which makes this bracket 0. Well, if I put x equals a half in there, 2 times a half minus 1 is 0. So the roots are x equals a half. And from the other bracket, what makes this bracket 0? Well, that's x equals 2. Okay, so those are my roots. Some people call them the critical values. Let's try sketching the graph. Okay, so let's draw or sketch y equals 2x minus 1 times x minus 2. Now, that is much like the graph I've already drawn in the box here, a parabola, and a parabola that's that way up, so if you like what I might call a happy parabola, a little bit like that. Okay, and let's put an x-axis in. Notice when I sketch graphs I tend to do the curve first, and the roots are at a half and 2, which means if I want to I can put a y-axis in about here, and there's the origin. And there's a little sketch of my graph. Now, just like in the blue box, I'm going to look for the bits where y, because y is now this bit, is greater than 0. And it's clearly greater than 0 where the curve is above the axis. And in terms of x, that means it's anything bigger than 2. Notice the open circle means I'm not including 2. And anything less than a half. And so I've indicated on the graph the values of x for which the graph is above the axis, in other words, for which 2x minus 1 times x minus 2 is greater than 0. So we can see, or we can say from our graph now, that the solution of this inequality here, of our original inequality, is, well, x is less than a half, or x is greater than 2. Okay, because it's on those blue lines that we've done, and that is a number line now. Right, so is that our answer? Well, not quite actually. There is one trick to this question, because of course if you look at this distance here, it's a length, and x can't be less than a half, because that would make that 1, wouldn't it? So, sorry, that would make that negative. So a half minus 1 is negative. So we need to say that somehow. And so let's do that now. So we can say, since x minus 1 is a length, we say that x must be greater than 1. And so we ignore that sort of bit underneath, the left-hand bit there, the x is less than a half, and so the answer is x is greater than 2. And we're done.